These are my favorite related rates questions. I hope you like them as much as I do. Remember, they are not my favorite questions. They are not my favorite thing to do in the world. They are my favorite related rates questions. All right, so there is no reason to start with 31 and then move to 10 and then move to 9, except because I feel like it. So, here's the deal. You have to read the question and you have to make some assumptions, correct assumptions, not out of the blue assumptions for this kind of stuff. But it says a ladder 3 meters long is sliding down a wall at 15 centimeters per second. How fast is the bottom of the ladder sliding outward when the top is 1 meter from the ground? Okay, so because I've got a ladder leaning up against a wall, I am going to draw a right angle triangle. So here is my ladder. Okay, so I am going to call this side here X because it is in the X direction. I'm going to call this side Y, and I'm going to call this side H for the hypotenuse. And it says that the ladder is 3 meters long. So this is 3 meters. It's sliding down a wall at 15 centimeters per second. That means that dy by dt is equal to not 15 centimeters per second, but negative 15 centimeters per second. And the reason for that is because this distance is getting less and less and less. So you have to put a direction in there. The question says, how fast is the bottom of the ladder sliding outward? So the question, as in the thing I'm going to give the question mark, is this, and that is sliding outward when the top is 1 meter from the ground. So that means the ladder's top is 1 meter from the ground, and I get to say that this is 1 meter. So you need two pieces of information on every side. So we've got 2 pieces of information here. We almost have 2 pieces of information here, and we don't have 2 pieces of information here until I start to fill this in. Now this is the easiest piece of information, and this is the assumption. So the assumption is that if this ladder is 3 meters long, it's not changing in length. So this side is not changing while the other 2 are. So that makes this 0 centimeters per second. It also means that I have a problem with my units. I've got centimeters, I've got meters, I've got centimeters, I've got meters. I'll want to kick this out in centimeters. I'll have this in meters. So I'm going to take a minute to actually find that X based on what I've got. So h squared is equal to x squared plus y squared. The hypotenuse is the longest side. H is 3. X is unknown. Y is 1. So I've got 9 minus 1 from the other side equals x squared. So that's 8 is equal to x squared. That makes x equal to plus minus root 8. And because x is the side of a triangle, we're not going to use the negative version. But I can take 8 and do reduced radical form with it. So the root of 8 is the same thing as the root of 4 times the root of 2. We can take the square root of 4. We cannot take the square root of 2. So now I have a value to put here, but it's in meters. So you have a choice. You can go through all of this and divide them all by 100, or you can fix the rate. As I explained to you in an earlier lesson, it's best not to mess with the rate, and it's best to take care of this. So I am going to not divide by 100, I'm going to times by 100. So this is 300 centimeters. This is 100 centimeters. And this will be 200 root 2 centimeters. And now I can start the question. And I start the question with the same line as I did up here because it is relating all the rates together. That is the Pythagorean theorem. And now I'm going to take the derivative. Now, this is a bit of a wonky derivative. It's still got 2 letters on one side and 1 on the other for a grand total of 3. But if you think back to the cylinder question, we needed the product rule. This is a plus sign. We don't need the product rule with the plus sign. We just have to take this derivative sort of implicitly. So take the derivative of h squared. 2h, we need a dh by dt. 2x, we need a dx by dt. Plus 2y, we need a dy by dt. And now we can look to our picture to find all the values that go in for things. So 2 times h is 300, times dh by dt is 0. There's the 300, there's the 0. On to the x's. 2 times 200 root 2 times dx by dt, because that's what we're looking for, plus 2 times 100 times negative 15. There's the 100, there's the negative 15. So all that work on the left doesn't matter. This is 400 root 2 dx by dt minus 30 times 100, 3,000. Try to get the dx by dt by itself. So I'm going to take the 3,000 across. And get dx by dt on one side. And finally, divide both sides by 400 root 2. Now, although it is not the best answer, dx by dt would be chop off 2 zeros, chop off 2 zeros, 30 over 4, 15 over 2 root 2. Now, I can totally understand if you don't like 15 over 2 root 2, and you'd rather turn that into a decimal so that you're talking about normal everyday numbers. So 15 divided by bracket 2 times root 2 is 5.30. And this should make sense, as this answer should make a bit of sense. If this is coming down the wall, which makes it a negative because we're closing in a distance, making it less and less as the ladder slides, this distance is getting more and more, which means it should be a positive. So back to the original question, how fast is the bottom of the ladder sliding outward? Therefore, the bottom is sliding out at 5.30 centimeters per second. Because remember, I kept everything in centimeters per second. All right, so flip to the next one. It's kind of the same. I'm going to take a little hand cramp break. All right, so let's just read through this, and then I want to explain how I know something. So at 1 p.m., ship A was 80 kilometers south of ship B. Ship A is sailing north at 30 kilometers per hour, and ship B is sailing east at 40 kilometers per hour. How fast is the distance between the two ships changing at 3 p.m.? So, I have a right triangle, and I will explain my thinking in a second. So ship A is south of ship B by 80 kilometers. And this is at 1 o'clock. Ship A is sailing north, so just to get another color. At 30 kilometers an hour. So because this is the up and down, I'm going to call that dy by dt. And because this distance is getting less and less and less, I'm going to say that that is negative 30 kilometers per hour. Ship B is sailing east. Obviously, I need work on my north, south, east, west. Give me a sec to move this stuff. And that 80 there we go. Ship B is sailing east at 40 kilometers an hour. So I'm going to say that that's dx by dt because it's in the x direction, and it's getting bigger, so I can just write down 40 kilometers per hour. And then the question is, how fast is this distance changing based on the fact that we now have a right angle triangle? So we've got a question mark for dh by dt. It is not 0 like the last question. The last question, the ladder stayed exactly the same length the entire time, so the hypotenuse didn't change, and you represent no change with a 0, as opposed to this one, which is saying, how fast is the hypotenuse changing? Now I'm sitting here thinking, you might question why I don't write down let t represent time in hours and then make the hypotenuse type equation that we did in the max-min questions. It's because this isn't a max-min question. It's just asking how fast. It's not asking us to minimize the distance or maximize the distance. It's just generally saying how fast. So you have to approach this with all these rates being related to each other, which is why you have a related rates question. So where does this 1 p.m. and 3 p.m. come in? Well, it means that my x is 80 kilometers an hour. Sorry, just 80 kilometers. Because ship B has been traveling for 2 hours at 40 kilometers an hour, so that's 40 each hour for a grand total of 80. And it doesn't mean that this is 80. It means that this boat, ship A, has been traveling for 2 hours at 30 kilometers an hour, so that means it's traveled 60. So our y value isn't 80 anymore. It's 20. And then we're going to have to figure out the hypotenuse using Pythagorean theorem. Probably good to use the correct version of Pythagorean theorem. So we're looking for h. X is 80 squared plus 20 squared. So h is 6400 plus 400. Don't know where these things are coming from. H squared is equal to 6,800. H would be equal to plus minus root 6,800. And I'm going to try to reduce radical form that. So 100 times 68 is 10 root 68. But 68 is divisible by 4, I think. Yep, 4 times 17. So I've got the 10, I've got a 4, I've got a 17. I can take the square root of 4, which is 2, leave the 17. So my h, and I'm only going to use the positive version because it's the one that makes sense, is 20 root 17. Yes, you can use a decimal, but if you're going into college or university calculus, it's not going to be acceptable. You want to keep all your accuracy. So, time for derivatives, because we need related rates, which are all about derivatives. So start with Pythagorean theorem again. The right version. Don't know why that keeps happening. Derivative. Tell me you took the derivative. Derivative. Tell me you took the derivative. Derivative. Tell me you took the derivative. Now, something I didn't do in the last question that I'm going to do here is everything's got to multiply by 2. So I can actually not multiply anything by 2, and I will have less multiplying to take care of. Now, you can't just write this down. And the reason is because this line is not the derivative of h squared equals x squared plus y squared. This line is the derivative all divided by 2. So now I can use my values. So h is 20 root 17 written above. dh by dt is what we're looking for. X, 80, dx by dt, 40. Plus y, 20, dy by dt, negative 30. So, going to do some math. It's all bad maths on the right-hand side. So it's 3200 minus 600. 3200 minus 600 is, oh my gosh, 32 minus 6, 2600. Isolate dh by dt. $2,600 divided by 20 is all I can legitimately do, so that's 130. So it's 130 from the numbers, and over the root 17 is still there. And of course, if you don't like that answer, and a lot of math teachers don't even like this answer because there is a root in the denominator, remember how you can fix that, and that is you can take 130 over root 17. You can multiply both top and bottom by root 17. That'll give you 130 root 17 in the numerator and just a straight 17 in the denominator. So that's another totally acceptable, probably better acceptable answer when you're in college or university calculus. And then the other option is that you are at a school that lets you use a calculator, in which case you just pile it all into the calculator and you get whatever that was, 31.53. And then you write me a little therefore statement. So it is evident, because I got a positive answer, it's evident that this distance is actually getting further, or a longer distance, because I ended up with that positive answer. So the distance between them changing is, so it is growing, increasing, at, oh, just to annoy some of you, this many, let's check our units, kilometers per hour. The end. Okay, so those are the triangle questions that I love so much. Here is the last one. Need a hand cramp break. And now that I look at it, I think, oh, I know why this one is the last one we do. So I'm going to take that little break and come back at you with the answer to this. This is a bit different. Okay, I'll be honest, these are my least favorite triangle questions. So although it's a triangle question, I don't really love it. So it's always about a lamppost. every single time. And these are actually quite easy to do. I just don't like them for some reason. It's sort of like, I like doing reduced radical form, but some people don't. It's not a difficult computation, but some people just don't like it. Quadratic formula, not difficult. I really don't like it. I'd rather factor. So this is a question that you will get, and it's a definite style of question, sort of like the other ones. I should mention that these ones don't have to be just like this one, straight north, south, east, west. They can be north, east, which means 45 degrees off of north, and they can be northwest and southeast and southwest, and then they make 90-degree angles in different ways. But back to this guy. So let's see how I oriented this. So I cannot make this movable. So I'm going to draw me a right angle triangle. I'm going to doodle it, just to be a rebel. So it says a man who is 2 meters tall is walking straight away from a lamppost at the rate of 4 kilometers per hour. So I have a lamppost, and I have a guy walking away from the lamppost. The lamppost is 40 meters high. The man is 2 meters tall, and I am going to draw a right angle triangle this way. Now, do you see that there's 2 right angle triangles? I hope that you do see that. So there is, and I'm going to color code it temporarily, maybe forever, depending on my mood. There is a right angle triangle sitting right here, and then there's a second right angle triangle sitting right here. Now what that means is that the way you have to tackle this question, yeah, it's temporary, is by doing similar triangles. So unfortunately, this part of the triangle we have to call something different than this part of the triangle. And I'll explain why in a minute or two. So the question says, actually part of the information says, a man who is 2 meters tall is walking straight away from a lamppost at the rate of 4 kilometers per hour. So that actually means that this distance here is growing at 4 kilometers per hour. It also means that all these numbers have to get changed before we even think about doing anything else, because this is in kilometers per hour and these are in meters. So how many meters in a kilometer? That's 1,000. I'm double checking because I'm on holiday. So 40 divided by 1,000 is 0.04. Kilometers. And 2 meters divided by, yes, I should be able to do this in my head. And I should be able to retain numbers better than this. And we get that. So you should have looked at similar triangles briefly in grade 10. Basically, they are comparison triangles. So I am going to just make sure you know that this is a right angle triangle. That's bad. And this is a right angle triangle. So what we have to do is we have to compare dimensions on one triangle versus the other. So that means if I compare the up and down on this triangle, and by compare I mean fractions, to the up and down on the smaller triangle, then I will have to compare this on the bigger triangle, which is a combination of x plus y, with this on the little triangle. So what I did, just to outline it a little better, I compared this to this, then I compared this to this. So I've got sides of triangles being compared. Big one is on top, little one is on the bottom. Now, I don't want to take the derivative of that mess. There we go. So I'm going to do a little cross multiplying here. It's a little fancier than what we're used to. Doesn't matter which one you do first. I'll do the slightly more complicated one first. So 0.002 times x, 0.002 times y, equals 0.004 times y. Now, it has just occurred to me that I haven't even read the question. It's been a long time since I've done this. So the question is, how fast is his shadow lengthening when he is 24 meters from the foot of the lamppost? So this x dimension, we know how fast that chunk is changing, but we don't know how fast just the shadow part would be changing. So that's our question mark. So dy by dt. Now, it's probably a good idea for me to collect like terms here because I've got some. So I'm going to take this across the equal sign. So I have my x's on one side and my y's on the other, which seems a bit more logical than having it mixed up. Now, because these are decimals, I am not trusting my brain. So 0.04 minus 0.002 is 0.38. I should have known that. So now I can take the derivative and not be too clumpy. Yes, I know there's question B. So the shadow is y. The walking distance is x, so that's why we had to separate that. And we do have to worry about the fact that x is 24 meters, which according to my calculations would be 0.024 kilometers. Crap, my color coding's all off. All right, so time for the derivative. Derivative of this side, simply this, but don't lose your dx by dt. Derivative of the other side, 0.038. No y anymore. Don't forget your dy by dt. Go looking for your values. So dx by dt is 4. Okay, that's how mistakes get made. Let's try that again. 0.002 times 4 equals 0.038. Oh my gosh, my hand is cramping up. Times dy by dt. We're trying to isolate dy by dt to get ourselves the answer. So I'm going to do two things at once here. I am going to multiply these two things together, which I think I can handle in my head. And to get dy by dt by itself, I'm going to divide both sides by 0.038. And I didn't save myself any time whatsoever. Sheesh. 0.002 times 4 divided by 0.038 equals, yikes. Terrible number. Do not expect nice numbers all the time in calculus class. So 0.21. So that is how fast the shadow is changing. Specifically, the length of his shadow. And we didn't even need to worry about this 24 meters. It never came into play. It's true that it was 24 meters, but because our x's disappeared and our y's disappeared, it didn't matter. So therefore, let's try that again. The shadow is lengthening. His shadow is lengthening at 0.21, and it'll be kilometers per hour because that's what we decided everything had to be in. All right, so B is the easy question. So if I want to know how fast the end of his shadow is moving, so that's this point right here, that is actually a combination of dx by dt and dy by dt, meaning that if I want to know how fast the end of his shadow is moving, we have to actually take dx by dt and add it to dy by dt. So that's 4 plus 0.21 equals, I can do this in my head, that. So then we need a therefore statement. Therefore, the end of his shadow, which is different than the lengthening, the end of his shadow is moving. Gotta stop talking and writing at the same time. Moving at 4.21, still with the kilometers per hour. Okay, there we go. So, glad that ended pretty quickly because my hand is super cramping up. But yay, I am done related rates in one day. Does that mean I should assign it all in one day? We'll see. Either way, there are the triangle problems. So have at her, and I will get back to you with the next unit. I may take a break and work on some grade 9 stuff because there is no rush to do this stuff at all. Anyhow, there you have it.